In section 4, we want to look at some theorems about zeros of polynomials. Specifically, we're going to be trying to find a polynomial given certain zeros. We want to find rational zeros of a polynomial, and we want to be able to determine the multiplicity of a zero from the function as well as from the graph. All right, before we look at some specific examples, there is a theorem we want to talk about that's called the fundamental theorem of algebra. That says that every polynomial function of degree n greater than or equal to 1, in other words, there's at least an x in the function, can be x by itself, an x squared, x to the third, etc., has at least one zero in the complex number system. I added the parentheses there, and no more than n. Remember, the degree, the highest exponent, is the limiting factor on the number of zeros. But we're guaranteed that if there's an x in the function, it will have a zero. It may or may not be a real zero. So let's take a look. If I want to find a polynomial lowest degree with specified zeros, I have to recall that a zero relates to a factor for the polynomial. So if I have -2 as a factor, a zero, then I will have a factor of x plus 2. If I have 0 as a zero, then my factor would be x minus 0, but we just say x. And then last, if I have 1 as a zero, then x minus 1 is going to be my factor. So in order to find the polynomial, I take my three factors and I multiply them out, simplify, and get the function f of x equals x to the third plus x squared minus 2x. Now, if I'm taking a quiz or a test and I want to double check myself, I would certainly graph this with my calculator and make sure that it is crossing at -2, at 0, and at 1. So that's a way to check. What if I have the zeros of negative square root of 3, positive square root of 3, and 4? Well, just like we did on this last example, we're going to turn each of those into a factor. So x minus the minus makes x plus the square root of 3, x minus the square root of 3, and x minus 4. A hint would be to go ahead and multiply the two factors together that have the radicals so that they can simplify nicely. That will give me x squared minus 3, then multiply with the x minus 4, and combine like terms, and we get x to the third minus 4x squared minus 3x plus 12. If you need help with multiplying, contact me or stop by our Academic Success Center for some help. All right, this one is going to involve some multiplicity stuff. It says I want a polynomial. It's going to be degree 4. -2 is a zero, so x plus 2 is the factor. Multiplicity 1, no exponents. 3 is a zero, but it's multiplicity 2. So notice that I have x minus 3, but I put an exponent of 2 on there. And then 0 as a zero of multiplicity 1, so we're down to plain x. So we have these three factors we want to multiply together. You can multiply in any order, whatever works for you. For me, it was easy to multiply these first two, and then also go ahead and multiply out the x minus 3 times x minus 3. Remember, it's times itself, so you will get that middle term. And then you can take x squared times all of this, 2x times all of this, combine some like terms, and I did it vertically because I think that's easier, and got my final function of x to the fourth minus 4x cubed minus 3x squared plus 18x.